Good morning, everyone. I'm going to be showing you a very brief introduction to a topic that is just a bit of an extension of what we did yesterday. If you look at the problem in front of you, triangles GHJ and GKJ are very familiar because it looks exactly like what we saw yesterday. Of course, there's a red box that's covering up the proof statement. Don't worry about that yet. Just know that it's a little bit different, but to start off, everything is the same. So what I'd like you to do, take the information that GJ bisects HGK, that's the given statement, and also that angle H is congruent to angle K, and identify your postulate. Choose the S's and A's that will prove that the triangle on the left is congruent to the triangle on the right. So at this point, person in control of the computer, go ahead and pause the video and allow the class a few minutes to find the postulate. Go ahead and pause now. All right. When we're doing this problem, I'm going to go through it real quick just to make sure everybody's on the same page. The first part of the given information, GJ bisects GK, or HGK, excuse me. That means that the line down the middle right here bisects the big angle here. So that makes that angle congruent to that angle. So there's some marks that we can use. Also, it tells us that angle H is congruent to angle K. Already we have two sets of A's involved here, and since we have two sets of A's, most likely it's going to be angle side angle or angle angle side. Quick side note, if you're doing a proof, there is always a postulate. Don't worry about a none answer when you're doing a proof. It's always going to work for you. Otherwise, the proof doesn't make any sense and you can't write anything. So, with that in mind, the other piece, and this is going to be information that we provide on our own. That would be the reflexive side, right in the middle. The reflexive property sharing the sides. So that will be GJ congruent to GJ. Now, what we have labeled here is going to be angle. Oh, that's not working the way I wanted it. It's going to be angle, angle, side. So we're going to use AAS to prove that these two triangles are congruent to each other. Now at this point, Mrs. Davis, if you would please, we're going to stop the video again and make sure the entire class is understanding why it's AAS and answer any questions that are necessary. Go ahead and pause the video. Very good. Let's go ahead and move toward our proof. Now, look at your list of how to write a proof. The first step that you're going to see is that we need to write the given information. So, as we go toward the proof, we know the first thing is going to be the given information, and then what comes next? We're going to write down anything else that we provided. In this case, that mark is red. After that, you move on and you get your proof statement. One triangle congruent to the other. So, again, pause the video and allow everybody to write the proof all the way down through where two triangles are congruent to each other. Go ahead and pause now. Very good. I hope most people have the proof together at this point. You might have had a little bit of problems with how the triangles are marked congruent. In just a second, I'm going to lower this gray area at the bottom of the screen, and you will see where all that is written. So let's go with this. First part is your given statement. GJ bisects HGK, angle H congruent to angle K. That is a copy of exactly what's given. So you have your statement and your reason. Step 2. I'm going to do step 2 and step 3 all at the same time, because step 2 and step 3 are interchangeable. It doesn't matter which one you had first. You have to mention something about the definition of bisecting, because remember, if they give you a definition, you're going to use its definition. No, I'm sorry. If they give you a vocabulary word, they expect you to use its definition as a reason. So the reflexive property is the obvious other part of this. So this is step 2 and step 3. Step 4. We say that the triangles are congruent to each other. Triangle HGJ congruent to KGJ. This is not given to us. We have to write the triangle congruence, just like we did it on the worksheet we checked in class yesterday. You know, that one that I turned back that a lot of people had to redo. You have to be able to identify which two triangles are congruent to each other. That's a skill, a very specific idea that has to be taken care of. So the reason they're congruent is by AAS. AAS is the postulate that we decided at the very beginning. Mrs. Davis, if you would please, we're going to stop the video and answer any questions we have to this point. Excellent. Let's finish this thing off. Now let's go ahead and reveal what's behind the red box. Hopefully, there it goes. It's taking a while. But it says that we want to prove that HJ is congruent to KJ. HJ congruent to KJ. So give me just a second. And what I'm going to do, I'm going to erase the marks we made to get everything started, just to clean it up a little bit. And we have now shown in step number 4 that one triangle is congruent to the other triangle. We know the two sides are now congruent. By the definition of congruent polygons, all the way back to the beginning of this unit, the definition of congruent polygons says two polygons are congruent if and only if all corresponding parts are congruent. And guess what they're asking us to show? They want us to show that two sides are congruent to each other. And it works out really well because HJ right here and KJ right here are corresponding. Since they're in the same position, inside two triangles that we know are the same size, they must be congruent to each other. Now let's look at this last step. The prove statement for this one is HJ congruent to KJ. It's always going to be the prove statement for that last statement. The reason is something called CPCTC. I'll address what that is in just a second. Do me a favor, please. Just write it down. CPCTC. Every other letter is a C, then you have PT in the middle of it. So, notice the dotted red line above that step. The reason I put that there is because everything to that point in the proof is the same as what we saw yesterday. We started off by looking at a pair of angles. There's another pair of angles and a pair of sides. We listed everything that we needed to. Then we said that the triangles were congruent to each other. Once we did that, all their parts then have to be congruent. And we can say step number 5 that HJ is congruent to KJ by CPCTC. Mrs. Davis, if you would please, we're going to stop the video and answer any questions that the students might have. Thank you. Very good. Let's get on to this CPCTC idea. I'm going to go ahead and go forward a page, and please write this down word for word. CPCTC means corresponding parts of congruent triangles are congruent. And In other words, if we can show the triangles are congruent, then we can go further and conclude that all their parts are congruent. Make sure that you get everything above the line, word for word. The stuff below it is kind of a layman's terms. If you want to, feel free to paraphrase that. CPCTC, corresponding parts of congruent triangles are congruent. If we can show the triangles are congruent, then all their parts then have to be congruent also. Let's keep going. Next proof. If you're in charge of the computer, please do me a favor and pause the video right now so that everyone can get the drawing and information into their notes. Excellent. Like before, we're going to find the postulate that says these two triangles are congruent, the one on top, the one on bottom. We have some information. The information we have so far is that we have one set of parallel lines, we have another set of parallel lines. As we went through the parallel lines information in class over the past couple days, there's one thing that it's trying to tell you to do. So make sure you keep that in mind as you look for the postulate here. Go ahead and pause the video, and everybody please look for the postulate that proves they're congruent to each other. This is not an easy one. Go. Well, hopefully, you made this work. And if not, we're going to go through it very quickly, get the explanation out there to clarify for everybody. And let's do this. We are going to use the Z, right? Use the Z. When we see parallel lines, we're always going to go to that idea. It's our go-to idea for parallel lines. And we're looking at the first part, DE parallel to GF. Right here's DE. Right here is GF. It says they're parallel. Let's highlight the diagonal. Do you see the Z? Of course it's backwards, but it doesn't too much matter. I'm going to go ahead and highlight the corners of that angle. Those are my alternate interior angles. So I know I have one mark there, and I'm going to go ahead and clean up just a little bit. And we're going to do it the other way. Same idea. But since we have two sets of parallel lines, we've already done parallel lines number 1. We're now going to do parallel lines number 2. DG, parallel to EF. Do you see the corners in this Z? Mark a corner there, mark a corner there. We now have two pairs of angles. Every time they are telling you parallel lines, they're always trying to get you to see alternate interior angles. Always trying to get you to see alternate interior angles. So the missing part, much easier. Much easier. We're going to use parallel lines. That's not parallel lines. That's reflexive property, Rhodes. What are you doing? We now have the reflexive property for the shared sides, and we have angle, side, angle, ready to go. ASA will be the postulate that proves that these two triangles are congruent to each other. If we need to, stop the video, make sure everybody's online, and then I'll be back in just a second. Awesome. Let's finish this up. I want to point out, we're not trying to prove that two triangles are congruent here, are we? We are trying to prove that two parts are congruent. We've got to go beyond the triangles, and we're going to add that one extra step on for CPCTC. So let's go ahead and write the proof. Let's go ahead and write the proof. Use ASA to show that these two triangles are congruent. You're going to write down your given statement. You're going to write down some parallel lines. You're going to write down some alternate interior angles. Remember, use 3 letters. You're going to write down shared sides based on the reflexive property. Finally, you're going to say that the triangles are congruent. Now, do me a favor. Stop when it says the triangles are congruent, because we've got to make sure that's all together before we move on. So go ahead and pause the video while everyone writes their proof. Wonderful. Let's finish this off. I'm going to bring the whole screen down at one shot. That's how far I ask you to go. Go ahead and look at everything, double check it. A couple quick ideas. Oh, don't want to do that. Where are you going? I need this. The given information. Then notice how we named all of the angles using 3 letters. That's your alternate interior angles that we got using the Z. The reflexive property is probably one of the easiest things to write down. And then finally, we wrote that the 2 triangles were congruent using ASA, because that was the postulate that we said we were going to use. Now, let's get this last statement. All we got to do is write down the proof statement, which they said was G congruent to E. And the reason is always CPCTC. That's always the last reason if you're proving parts. Always the last reason if you're proving parts. Now, while I'm here, I forgot to do this on the first one, admittedly, and I need to apologize to you for that, but I need to add a phrase to CPCTC just to make sure people understand its usage. This is going to be CPCTC after, that's the word after, ASA. Always do CPCTC after whatever postulate you're using. I want to reinforce the idea that it always comes after you prove that the 2 triangles are congruent to each other. CPCTC after SSS. CPCTC after SAS. Whatever it is, it's always going to be after. Okay? So, go ahead, pause the video, clean up any questions, and I'll be back. And what I need you to do before I get started again, get out your essential questions and turn it over so we're looking, or no, get out your commitment contract so you can see your essential questions. We're going to answer that last one very quickly. All right. What can be assumed if 2 triangles are congruent? Folks, we just saw it. Corresponding parts of congruent triangles are congruent. CPCTC. That is the answer to the second question. I will not allow you to write CPCTC on tomorrow's quiz. You must write out the phrase, corresponding parts of congruent triangles are congruent. You've got to know what it means. Just to know the letters isn't nearly enough. You have to have a full understanding of what it does. So you have both answers, you have both questions. Make sure that you have that going on for tomorrow. Guys, with that, I'm done. If you have further questions or you'd like to see more examples, be sure and ask Mrs. Davis. She's very knowledgeable. She'll be able to answer anything you need. Tomorrow, you have a quiz on this. Make sure you're studying it. Make sure you're looking through your examples. And I will see you all tomorrow.